So in the Leontief input-output model, we may not think anything of taking an inverse, other than it being an operation that needs to be conducted in order to solve an equation. In our case, that equation was, we wanted to know the total output of each of the sectors, and in order to calculate that, we had to take I minus the consumption matrix, the inverse of that, and multiply it by our final demand vector. Well, here was the matrix that we inverted, and if we compute that inverse, we get this matrix down here. And at first sight, those values may not mean a whole lot, but keep in mind that this is a matrix in its own right. So to get this final output right here, in order for that to take place, that is going to require a matrix vector product. So 1,000, the number of total final demand units from manufacturing, and I'm going to round some of these, 2.9, 0.9, 0.4, plus 7,500 times 1.8, 2.0, 0.4, plus 800 times 0.8, 0.4, and 1.3. And that's what's going to give me this matrix, or this vector here, 1673.1.5, 16143.5, and 4541.67. So what can we learn from this? Well, first of all, before we get into the analysis of this linear combination of these vectors, let's go ahead and remember that this is the final demand. So I'm going to abbreviate these, but this is the units of manufacturing that need to be input into the system, right? That's how many total units of output that are going to be required. Actually, although we know that that is the total final output, I'm going to think about this as what needs to be input into the system in order to output 1,000 units of manufacturing, of output as the final demand. So the language is going to be a little bit weird here for a second, but I just want to make sure that we can make sense of these units. So this is how many units of agricultural input need to be fed into our system in order to be able to output to, let's say, a city, units of agricultural output. And I'll do the same thing here. Units of service input into the system. This will give me units of service output to the industry. Well, in order for that to take place, in order for us to get units UMO into UMI, the units of every quantity inside of here would have to be, well, let me think about this. What times UMO would give me UMI? Well, from a dimensional analysis standpoint, I need to cancel out UMO units, and I need to introduce UMI units. Interesting. So the way we can maybe think about this right here is that we have 1,000 units of manufacturing that needs to be output to the city, and that means that in order to meet our total 1,000 units here, it's going to require 2.8 units of manufacturing input for 1 unit of manufacturing output. Now, how could that be? Well, the only way that could be is because we were taking into account how all of these other two industries feed into one another. That means that in order to output 1 solid unit, I'm going to need 2.8 units of manufacturing input. Now here, the 7,500 could be thought of as the units of agricultural output that we need to give to the city, which means that there are going to be 1.8 units of units of manufacturing input required for 1 unit of agricultural output. So this is going to tell us how sensitive our changes in final demand, or what sensitivity that's going to create on our final output. One of the things that we see here is manufacturing seemed to be, by and large, the greatest total production. And if we look at the coefficients, we'll see why. Every unit of manufacturing output requires almost 3 units of manufacturing input in order to feed the other sectors. Agriculture requires nearly 2 units of manufacturing input, and services doesn't really consume much of anything, which makes sense, since that's why we get these low figures here. But again, we could say that 800 is the units of services output, and this would mean right here that we would need 0.8 units of manufacturing input for 1 unit of services output. Now we can see that the units are going to work out. They're going to cancel. UMO times UMI over UMO, UAO times UMI over UAO, and the USOs will cancel out here, and we'll be adding together the total number of units of manufacturing input that need to go into our system in order to meet all of the demands. So we can see that if you increase the production, for example, of manufacturing by 1 unit, that's going to have a much bigger impact on manufacturing than it will on agriculture and services. So manufacturing changes create a big sensitivity in the system, but then changes by 1 unit to the services, if I change this from 800 to 801, then the required units of input for the 3 different sectors would only change by 0.8, 0.4, and 1.3. And so this helps us kind of see how changes in our final demand will affect our entire system.